Hello everyone, this is Kalpana here. In this video, we're going to see a problem from partial differential equations. So let's get going. So here are the notations we're going to use, and the given problem is find the partial differential equation from z equal to ax plus by plus square root of a square plus b square, where a and b are arbitrary constants. So we are given a relation z equal to ax plus by plus square root of a square plus b square. So we are going to find the partial differential equation from this relation by eliminating the arbitrary constants a and b. Okay. So here we are going to find PDE by eliminating the arbitrary constants. Right. So consider the given differential equation. So not the differential equation. Given relation as equation 1. Now we'll partially differentiate 1 with respect to x and with respect to y. Partially differentiating 1 with respect to x. Okay. So firstly, I'll show you the direct way of solving the problem, and next we'll see I'll increase the number of steps. Okay. So here we have to partially differentiate equation 1 with respect to x. So y will be treated as constant and z is a function of x and y. So we'll get dou z by dou x equal to a into partial derivative of x with respect to x is 1 plus, since we are partially differentiating with respect to x, so y will be treated as constant and here by will be treated as constant. Okay. So the partial derivative of a constant by with respect to x is 0 plus, again you are having constant, right, some constant. So partial derivative of a constant with respect to x is 0. Since we have a notation dou z by dou x equal to p, so let's replace dou z by dou x by p. You'll get p equal to a, right? Therefore p equal to a. Consider it as equation 2. Now partially differentiating 1 with respect to y, right? Since we are partially differentiating with respect to y, so we will treat x as constant. So ax will be constant and z is a function of x and y. So we'll get dou z by dou y equal to partial derivative of constant with respect to y is 0 plus b into partial derivative of y with respect to y is 1 plus partial derivative of constant with respect to y is 0. This gives us, since we have a notation dou z by dou y equal to q, let's replace this by q. We'll get q equal to b. Therefore q equal to b. Consider as equation number 3. Right. Now observe 1, 2 and 3. Okay. See, by replacing a by p and b by q, ab gets eliminated from 1, right? So now we have 1, that is z equal to ax plus by plus square root of a square plus b square. Substitute 3 and 1 we get, see from 2 we have A equal to P, and from 3 we have B equal to Q, right? Now we are going to replace A by P and B by Q in 1. Then you'll get Z equal to, replace A by P, you'll get Px, plus replace B by Q, you'll get Qy, plus square root of A square, P square, plus B square is Q square, which is the required partial differential equation. See, A, B got eliminated. You don't have any arbitrary constants here, right? And this is some function of x, y, z, p, q equal to 0 form. I mean, this equation is of this form, so we can say that it is a required partial differential equation. Therefore, z equal to px plus qy plus square root of p square plus q square is the required partial differential equation. So this completes the problem. Now let's see how to find partial derivative of 1 with respect to x and y in detailed way. So we have considered this as equation 1, right? Now let's partially differentiate 1 with respect to x. Right? So we'll apply dou by dou x on both sides of this equation. Right? Since z is a function of x and y, so we'll get dou z by dou x here equal to dou by dou x of first term plus dou by dou x of second term plus dou by dou x of third term. Right? Since we have a notation dou z by dou x equal to p, so let's replace it by p. You'll get p equal to, here we are differentiating with respect to x, that is partially differentiating with respect to x, so y will be treated as constant. So we'll write this as a into partial derivative of x with respect to x plus partial derivative of constant with respect to x is 0. Since we are partially differentiating with respect to x, so y will be treated as constant. Okay, so we'll get partial derivative of constant with respect to x is 0 plus partial derivative of constant with respect to x 0, which gives us p equal to a into partial derivative of x with respect to x is 1. So this gives us p equal to a, which is considered as equation 2. Okay, now partially differentiating 1 with respect to y. Right? So let's apply dou by dou y on both sides of 1. Since we are partially differentiating 1 with respect to y, so here x will be treated as constant. So here ax is treated as constant and square root of a square plus b square is treated as constant. Okay. This gives us, since z is a function of x and y, so you'll get dou z by dou y equal to partial derivative of first term with respect to x plus partial derivative of second term with respect to x plus partial derivative of last term with respect to x. Right? Since dou z by dou y is q, which is a notation, so let's replace it by q. You'll get q equal to partial derivative of a constant with respect to y is 0. Since we are partially differentiating with respect to y, so this x is treated as constant. So finally you have constant here, ax. So the partial derivative of a constant with respect to y is 0. Plus here we are having y, right, variable. So let's write it as b into partial derivative of y with respect to y plus partial derivative of a constant with respect to y is 0, which gives us q equal to b into partial derivative of y with respect to y is 1. This gives us q equal to b. Consider it as equation 3. You got the same thing, right? Fine. Now observe 1, 2 and 3. So we have noticed that by substituting 2 and 3 in 1, the arbitrary constants a, b gets eliminated from 1, right? So let's substitute 2, 3 in 1. We have equation 1, z equal to ax plus by plus square root of a square plus b square. Substitute a and b in 1, otherwise 2 and 3 in 1. We get z equal to, replace a by p, since a equal to p, b equal to q. So replace a by p and b by q. You'll get px plus qy plus square root of p square plus q square. It does not contain any arbitrary constant, so therefore z equal to px plus qy plus square root of p square plus q square is the required partial differential equation. And also this is of some function of x, y, z, p, q equal to 0 form, right? I mean, this is of the equation f of x, y, z, p, q equal to 0 form, right? So this is a required partial differential equation. So this completes the problem. Well, we have seen a problem from partial differential equation in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.